Hello, I am BJ at Seoul National University. In the introduction, I briefly touched on troubles in arithmetic of zero. In the four following videos, I will show that they are due to confusion in the sizes of infinity in the arithmetic. I'll begin with discussing infinity multiplied by zero. There are 9 field axioms in real numbers, which allow arithmetic of real numbers. F3 is existence of unique additive identity. There is a unique element 0 such that x plus 0 equals x for all real number x. F9 is x open y plus z close equals xy plus xz. From these two axioms, we can prove that all real numbers multiplied by 0 is 0. By axiom F3, this. By axiom F9, this. And again by axiom F3, this. Thus, 0 equals x multiplied by 0 for all x in real numbers. And what about infinity multiplied by 0? The simplest concept of infinity is that there is no largest natural number. Given any candidate n as the largest natural number, we can always contrive a larger natural number like n plus 1. Thus, natural number n is infinite so that the cardinality of natural numbers, called n, which is the number of natural numbers, is infinite in size. This cardinality of natural numbers was denoted as Aleph-Null by Cantor. Cantor considered Aleph-Null to be the cardinality or size of the set of natural numbers n, thus tried to evade as an element in the set of natural numbers because there is no infinite natural number. This may have been a cunning way of evading the conundrum of making a term for a natural or counting number for infinity, which is not in the set of natural numbers. However, the fact that Aleph-Null is a counting number cannot be eluded because Aleph-Null is the result of counting the number of elements in the set. We take it as a premise that if there is a one-to-one correspondence between the two sets, they have the same cardinality. This premise leads to the paradox that some part can have the same cardinality as the whole, but we accept this paradox in the theory of infinity, and in fact, this concept that the whole can be the same size as the part is the definition of Dedekind infinite. In any textbook, you can find Aleph-Null equals Aleph-Null plus 1 equals Aleph-Null plus Aleph-Null equals Aleph-Null multiplied by Aleph-Null. And you can easily prove Aleph-Null equals Aleph-Null plus any natural number m equals Aleph-Null multiplied by m. Then we can prove Aleph-Null is not a real number. If Aleph-Null is a real number, Aleph-Null needs to satisfy the field axioms in real numbers. However, Aleph-Null has multiple additive identity elements, thus does not obey axiom F3. And Aleph-Null requires a qualifier that y and z need to be larger than or equal to 0 in axiom F9. Otherwise, it leads to a subtraction problem like Aleph null minus Aleph null, which is indeterminate. Therefore, Aleph null is not a real number. Because Aleph null is not a real number, and more specifically, Aleph null does not follow F3 and F9 that are required to prove this corollary, we cannot state Aleph null multiplied by 0 equals 0 by this corollary. Because Aleph null is the number of elements in the set of natural numbers, Aleph null may be rephrased as like this. Then Aleph null multiplied by 0 is this, which we need to know. Then we'll take it as a premise that Aleph null multiplied by 0 is a single real number, which is very reasonable. And then we can prove Aleph null multiplied by 0 equals 0. Even though there is no unique additive identity for Aleph null in axiom F3, 0 equals 0 plus 0 holds. Thus, this. And because y and z equals 0, even though x is Aleph null, axiom F9 holds. Thus, this holds. Because Aleph null multiplied by 0 is a single real number by the premise, it follows axiom F3, thus this holds. Thus, this is true. Thus, 0 equals Aleph null multiplied by 0. Thus, we proved Aleph null multiplied by 0 equals 0, and it resembles something we have in current mathematics. Lebesgue measure of natural numbers, or any countable set, is 0. But it has very interesting illusion and delusion in its proof. Its proof is like this. Define a ball S with center n and radius of epsilon over 2 to the power of n. Then lambda n, which is the length of natural numbers, is smaller than or equal to 2 epsilon. Because epsilon is arbitrarily small, lambda n equals 0. This proof employs the concept of convergence and limit, which is flawed. However, the result is consistent with our intuition and is the same as Aleph null multiplied by 0 equals 0. Thus, it gives an illusion that the proof is correct and a delusion or false belief that the concept of convergence and limit is valid. In mathematics, the fact that the answer is correct does not mean that the proof itself is correct. A delusion in the concept of convergence and limit led to the many paradoxes and counterintuitive conclusions to be discussed later. In the next video, I will discuss C multiplied by 0. Please send critical comments to this address. Thank you very much.